today we are going to focus on multiplying binomials. So when we talk about binomials, we mean two terms. So something like, let's do plus 7. So we have two binomials. This is a binomial because there are two terms. This is a binomial because it's two terms. So anything with two terms is considered a binomial. Three terms, trinomial. More than three would be polynomial. These are all also called polynomials, but when we can categorize them by the number of terms, monomial 1, binomial 2, trinomial 3, polynomial more than that. So in this case, we have multiplying binomials. And we need to remember that when we multiply binomials, we're going to use the term FOIL, first, outer, inside, last. And the way that I try to explain it or liken it, it's sort of like a double distribution. Double distribution. So we're going to take the first term, we're going to distribute it into that binomial, and then we take the second term and we're going to distribute that into each of the terms. That's why I call it double distribution. But if we look, we see that when we take the first and we multiply that, that is the first. It's the first times the first. The first in the binomial times the first. And then that next distribution is the first times the last. Or excuse me, the first times, that's the outside. So we notice that that is the outer. This is the first. Then you multiply the outer two. Then you, well, let's do this too. O is outer, I is inner. So you notice that we multiply these. These are the inside two. That's the I. And then the L stands for last, and that's that last distribution. And you notice that you multiply the last of each binomial. So if we write it down, we have x times x plus x times 7 plus 4 times x plus 4 times 7. This is your firsts. This is your outside product. This is your inside product. And these are the product of your lasts. So that's where we get the term FOIL. When we multiply x times x, we get x squared. X times 7 is 7x. 4 times x is 4x. 4 times 7 is 28. And we notice that we actually have like terms here. My outside and my inside are going to be like terms, 7x plus 4x. So you're left with x squared plus 11x plus 28. That would be your answer of the product of those two binomials. You'll notice that this is your first, this is your last, and or excuse me, this is your first, this is your last, and this ends up being the outside plus the inside. So the sum of those two. Now, we want to do this and we want to notice similarities and patterns. So we look at these three examples and we see that the signs of the binomial are the same and they're both positive. So what is that going to produce? What is my answer going to look like? Are we going to notice some patterns here? So if we do firsts, outers, inside, and last, you get that. And then we can combine that. So my answer is x squared plus 13x plus 12. My firsts, my outer, my inside, and my lasts. We notice the outside and inside. We can add those two together, and we get that as our answer. My first, my outside, my inside, my lasts, and my outside and inside can be combined because those are like terms. and we get that. So let's take a look at these three solutions. Let's look at the solutions here. Let's look at this one, and this one. All right, let's not worry about this part yet. Let's look and see, what do we notice? What do we notice that are the same? What do we notice that are different? Well, the first thing you should notice is that they're all plus 12. Why is that the case? Why are they each going to be plus 12? Well, because that last is this times this. So I get that because it's going to be 1 times 12 is 12. 6 times 2 is 12. 3 times 4 is 12. So the product of those two will always produce this end constant. Okay? What do we also notice? Well, hopefully you noticed that this number ended up being the product of these two numbers, 4 and 3. 4 plus 3 gave me 7. 2 plus 6 gave me 8. 12 plus 1 gave me 13. Well, how did we get that? Well, look at that. 1 plus 12, positive 1 and positive 12 made positive 13. Positive 6 and positive 2 made positive 8. Positive 3 and positive 4 made positive 7. So the way we get that middle term is by the sum of those two constants. And the way that we got these two is by multiplying. So this was the sum, this was the product. Let's see if it holds up if we change it around a little bit. So we change the binomials a little bit. So instead of, the signs are still the same, but this time they're both negative. How's that going to affect my solution? So let's do the firsts. We're doing the firsts. We're doing the outside. We're doing the inside. And then we're doing the lasts. We still have our outside and inside are still going to be like terms, so I can combine those. That gives me x squared minus 21x plus 20. Let's just erase that for the time being so I can write my next one. Let's do the next one. That's x squared, outside, inside, lasts. That produces x squared minus 12x plus 20. Firsts, outside, inside, lasts. X squared minus 9x plus 20. So let's see what we observe again. Hey, I see that this is all positive 20s. So all those lasts are the same again. Why is that? Because negative 20 times negative 1 is positive 20. Negative 2 times negative 10 is positive 20. Negative 5 times negative 4 is positive 20. Now let's look at this term. How does this term come to be? Well, that is by the sum of those two. So do we notice that negative 20 and negative 1 is negative 21? Negative 2 and negative 10 is negative 12. Negative 5 and negative 4 is negative 9. All right. So we notice that when the signs are the same and they're either both positive or both negative, you notice that my third term ended up always being positive. Always ended up being positive. This is positive, this is positive. And it's because we notice that the signs are going to be the same. A negative time or a positive times a positive is always going to produce a positive. And a negative times a negative is always going to produce a positive. And we notice that when we add the same signs, we just get a bigger negative. We have a negative plus a negative gave us a bigger negative. When we had a positive 1 and a positive 12, that gave me a bigger positive. What happens when the signs are different? So now we notice the signs inside the binomials are different. And in this first iteration, we notice that the signs are different and the bigger number gets the positive sign. So we have 1 and 12. 12 is bigger than 1. So this case, the positive went to the bigger number. These are just examples. There's no rhyme or reason why the 12 got it. These are just examples. We want to see what it's going to produce. So my first, my outside, my inside, and my last. That produces x squared plus 11x minus 12. My firsts, my outside, my inside, and my last. That produces x squared plus 4x minus 12. My firsts, my outside, my inside, and my last. That gives me x squared plus x minus 12. So what do we notice? Well, this time, this constant at the end are all negative and the same number, negative. Why is that true? Well, hopefully you see that you're multiplying a negative times a positive, and a positive times a negative, and a negative times a positive. So when the signs are different, that last term is always going to be a negative because the signs are different. When you have a negative times an opposite sign, which is a positive, you're always going to produce the product is always going to be a negative number. All right, and then we notice that when we combine -1 and +12, you get +11. +6, -2, +4. -3, +4, +1. So we notice that all of our middle terms are going to be positive because we know the signs are different, so we have to take subtraction of both of these, and we have more positives than negatives. We have 12 positives, 1 negative, 6 positives, 2 negatives. So we're always going to have an abundance of positives, so I'm always going to have a positive as my middle term when my signs are different and the bigger is positive. What happens when the signs are different and the bigger is negative? What could we assume about that middle term? Hopefully your answer right there was that I can assume that my middle is going to be negative. So my firsts, my outers, my inners, and my lasts. That gives me x squared minus 19x minus 20. My firsts, my outsides, my insides, and my last. X squared minus 8x minus 20. My first, my outside, my inside, and my last. So because the signs are different, we would assume that we're going to get a negative product, a negative value here. And because my signs are different and the bigger is negative, that my middle is going to be negative. I'm going to have more negatives. -20, +1 gives me -19. +2, -10 gives me -8. -5, +4 gives me -1. So those are shortcuts. You should be able to look at a problem and be able to do mental math depending on what the two starting binomials are. So we know, looking at this, that my third sign is going to be negative, or my second sign is going to be negative, and my middle sign is going to be positive because the signs are different and I have more positives than negatives. So I get x squared plus 5x minus 36. This is negative because I know that this is always going to be a product of two numbers. And this is always going to be the sum of two numbers. It's the sum of the outer and the inner. This is going to be the product of the lasts. So we see that we have, didn't mean to do that. So we know, yeah, let's get rid of that. We know this is going to be the product and the sum. The sum will go in the middle, the product. Now, we notice that with each of these examples, also something we should notice is that our firsts are always a variable with no coefficient, or a coefficient of 1. So we notice that each of these always is x. If we have a coefficient in front of that x, it's not going to work. We don't use this shortcut. It will not work, this shortcut, and this is a shortcut because we're doing mental math. So we have to notice all of these uniqueness, these patterns. So this pattern only works if my x's, if my firsts are a variable with a coefficient of 1. So we'll notice that it always produces x squared. And we can use this shortcut in that manner. So the next question for you is, what if I give you the solution? What if I give you the trinomial? What if I give you, let's do, what do we know about those two binomials? What is going to produce this answer? What two binomials are going to produce this answer? Well, we should be able to look at this and derive some stuff. So this tells me something. What do I know about, oh man, I'm getting some crazy, I mean to do that each time. What do we know? What does this tell me? If this third, or the second, if the third term is negative, what do we know about the signs inside here? What do we know? We should know that the signs are going to be different. That's the only way, because this is a product. The only way you can get a negative through a product is if one is positive, one is negative. And what are the possibilities? What are the numbers that can go in here? What are the numbers that we can put in here that would produce a negative 14? Well, you could put in a positive 14 and a negative 1. You could put in a positive 1 and a negative 14. Those would produce that as the last. You could put in positive 7 and negative 2. Or you could put in positive 2 and negative 7. So those are the 4 possible numbers that can go in that would produce negative 14. Remember, this is a product of the lasts. So positive 4 times negative 1 gives me negative 14. Positive 1 times negative 14 gives me negative 14. Positive 7 times negative 2 gives me negative 14. Now, which one produces a negative 5? So if I have my lasts as positive 14, what would my middle be? What would my middle be for this first one? It would be 13, right? So does that equal my middle? Nope. This would give me negative 13. This would give me positive 5. And this would give me negative 5. So I know that this must be my answer. Now what would my first be? Well, because it's x squared, we know that it's always going to be. So my answer to this, if I factored x squared minus 5x minus 14, this would be my answer. Now, I'm going to teach you a much easier, well, easier, this is easy right now, but we have to learn when x squared doesn't have a coefficient of 1. But this just helps us with understanding what our possible binomials would be. So, good luck. Hope that helps. Come and see me.